What we've learned so far is how to graph quadratic and how to factor quadratic and how to find the x-intercept, how to find the vertex, the axis of symmetry, and the y-intercept of quadratic. So today we are going to use everything we've learned to solve questions related to quadratics. So basically, quadratics is anything that deals with a trajectory or a projectile. So what you're looking for things that what's the highest point that it reaches, what's the lowest point that it reaches, when does it touch the ground, where did it start, what's the height that it started from. So all of these things that you are looking for. So for example, so a footbridge over Huron Line in Windsor is used by students attending Forrester Collegiate. The bridge's arc over the road from a parabolic curve represented by the equation h equals negative t squared plus 16, where h represents the height of the bridge at the center in meters, and d represents the horizontal distance in meters from the bridge's center. So what this is saying, it's saying that h is the height of the bridge from the center, and then it's saying that d is the distance, the horizontal distance of the bridge, also from the center. So sketch a graph of parabolic curve. So if I'm looking at this, right, what I know here is I know it's quadratic. I know because a is negative, I know it's going to be opening down. I'm going to sketch something. And I know that because remember that it should look like this, ax squared plus bx plus c. And remember that the sign of a tells me if it opens up or down, and c is your y-intercept. So remember that the number with no letter is your y-intercept. So in this case, I don't have that middle term. I have the first term and the last term, and I know that a is negative, so I know it's going to open down, and I know that the y-intercept is going to be at 16. Now, a sketch without actually finding the good points, it means nothing, right? So I need to find these special points that we have been looking at. So in order for me to sketch this, I probably want to find the key points, which are the x-intercepts, the y-intercept, and the vertex. So remember that to find the x-intercept, you need to put it in factored form. So the first thing you need to do is you need to factor this. And to factor this, there's different steps that we need to do. There's the common factoring, which is always you're going to have to ask yourself as first question, can I do a common factor? And in this case, if I'm going to do a common factor, it's going to be a -1 because you see that negative in front of the d square. I don't want that. So I want to factor a -1 out. And then I'll have d squared minus 16 left. So now you see that if you look at this, this is a difference of squares because I have a squared term, and a minus between them. So if you remember the a squared minus b squared, and that's equal to a minus b, a plus b, right? So this is the difference of squares. So keeping that negative outside, and it's gonna be d minus square root of 16 is 4, and then d plus 4. So this is the lesson that you learned on Monday, right? With the difference of squares. So now this is in factored form, and factored form is useful because in factored form I can find my x-intercepts, and my x-intercepts in this case d minus 4 equals 0, so that means d equals 4, and then d plus 4 equals 0, so that means d equals -4. So both my intercepts, so my x-intercepts are at 4 and at -4. I know it opens downward. Now, so what I have so far, so I have the two x-intercepts. I know the y-intercept, we already talked about that. So I know the x-intercept. And I know the y-intercept, we already said that's 16. Now you can find other points by plugging in values as they did here. So anything, because we know that this is 1 and this is 1, right? Remember we also said before that we can find the vertex. And remember, like what they did here, they did something different, but I'll explain this to you later. Okay, so we can find the vertex by finding, first of all, the axis of symmetry, right? And to find the axis of symmetry, I'm gonna add the two zeros or the two x-intercepts and divide them by 2. So I'm gonna add -4 plus 4, divide that by 2. That's gonna be 0 over 2, which is equal to 0. So my axis of symmetry is at 0. And then to find the maximum height, I plug in 0 into the equation. I don't know if you guys remember this. So -0 squared plus 16, and that's going to be 16. So my vertex is going to be at 0, 16. And now I can sketch my graph. I have 3 important points. I can sketch them. Now, another way to do this is to plug in numbers between the two x-intercepts. So let's say what they did here is they plugged in -3, -2, they plugged in 2 and 3 into D, and then they found the answer and they sketched it. That's another way that you can do that. Okay, so I personally recommend that you find the x-intercept and you find the vertex, because it is one of the like knowing what the vertex is and knowing what your x-intercept are helps you sketch the graph. Now, so what's the question? So we did sketch. Okay, so let's go back up here. Now, what is the meaning of the x-intercept in this problem? So remember that this is a bridge, right? And what is the meaning of the x-intercept? So the x-intercepts could be the points where the arc is at the level of the walking leading up to the footbridge. So basically, this is the middle of your bridge right here at the 0, 16, right? So 4 meters to the left and 4 meters to the right of that vertex is where the start of the bridge is, right? So it's where the bridge touches the ground. What is the span length of the footbridge? So the x-intercepts are 4 units to the left of the center and 4 units to the right. Therefore, the bridge span is 8 meters. So if you look, since you're starting right here, your bridge is starting right here, right? This is where it's touching the ground, and then ending right here. That means the span of this bridge is 8 meters. For what values of D is a quadratic model not valid? So remember that the bridge is going to start at the ground and then it's going to end at the ground. So anything below -4 and above 4, it's not going to be valid, right? So the way we're going to answer this, we're going to say that any values less than -4 or greater than 4 are not valid. The bridge would go underground past these values. All right. So not only that you have to understand how to graph and how to find the points, you also have to understand what the question is asking you, and then what is the meaning of these values. Now, this question was easy, right? Because, I mean, if you know how to factor and you know when you factor that you're finding the x-intercept and you know how to find the vertex, it's pretty straightforward. It's just you need to know what you're doing, and you need to know that whatever we've learned before, we're going to have to use to solve these problems. Now, sometimes we can't factor. Sometimes it's harder to factor. And then we need to figure out another way to solve the problem. And that's when we're going to have to use technology. So let's read this question. So the path a football follows through the air can be modeled by the equation h equals negative 0.003 d squared plus 0.47 d plus 5.5, where h represents the height of the football in feet and d represents the horizontal distance in feet. How far did the ball travel before hitting the ground? So we have a ball. And the ball was kicked into the air, went up, and then it's gonna reach the ground. Now, why did I not start at the ground? Why basically I started like this? Because you see this? This tells me that the y-intercept is at 5.5, right? So that means the ball was not on the ground when it was kicked. It was somewhere in the air, right? So so basically this part here is like we don't count that part. Okay, so the height of the ball when it was kicked was at 5.5, and then it's gonna go up, reach a maximum, and then it's gonna hit the ground sometimes like so many meters away or so many feet away. Now, how can I graph this? This is a sketch. How can I graph it? So I can't factor this. It's pretty, it's not easy to factor. There is a method that we use, and it's called the quadratic formula, but we don't learn in this course. So what we're gonna have to do, we're gonna have to use technology to graph. And the technology that we're going to use is called Desmos. Okay, in the assignment, it's gonna say use WinPlots or whatever it is. Don't use that, just use Desmos. Okay, so you're gonna type Desmos, and then you're gonna see, you're gonna go to Desmos beautiful free math, and then you're gonna click start graphing. Let me just clear this. And in Desmos, you can actually type whatever equation you need. So in this case, we're gonna type the equation that we have, and the equation is h equals negative 0.003 d squared So to do h squared, you can either use that button here or that button right too, or you can do the hat, something that looks like a hat on your computer, shift six, and that will give you the subscript or superscript. Plus 0.47d plus 5.5. And let's see, okay, so we have to write it in X and, sorry, that's gonna be a D on here. That should work. There we go. There you go. So what you can do, so you see that minus, you can press on that minus to be able to zoom out plus zoom in, right? So you can see this. All right. So if you look at this graph, right, this is where the initial point is. This is the y-intercept 5.5. And then if you look at this is the vertex, right? And then if you look at this, these are your x-intercepts. So the ball will hit the ground. The ball will hit the ground when it touches the x-axis, right? And that's going to be at, there's two values here. There's a negative 10.938 and then there's a 167.605. Now, obviously this part here, the negative 10.938, we don't count that because the ball was hit at 5.5. At 5.5, and then it's gonna reach the ground at 167.6. So, so here's your football throw. So you have the two zeros, but then again, we're gonna omit the negative because negative distance for the ball, we're not gonna, like this is something that you can ignore. And we know that the ball was hit at 5.5. All right. Now, what I want you to try first before you try using Desmos is try factoring and see if you can factor. You can use Desmos to see if you can factor. So you see here, when I used Desmos, it was clear that I can't factor because look at my zeros. My x-intercepts have decimals. And if they have decimals and like so many decimals like this, then for sure I can't factor. Okay, so if you end up graphing and then your zeros end up having decimals, then most likely you will not be able to factor. Okay, otherwise, if you can factor, always think about common factoring first, and then using either sum and product or difference of squares to factor. Okay, if you have any questions, I will be on Zoom this Friday, so make sure you log in and ask me any questions you have.